Hey guys, and welcome back. Well, I've got another cluster that is currently being spun up using EKS-CTL over here. This will be a fresh cluster for us to work with, but I kind of wanted to show you what our desired state is going to be after we have deployed the cluster autoscaler feature. So over here, I've got another cluster that's already been running for a little while, and I've already installed the cluster autoscaler feature on this particular cluster. And as you can see, I've actually got a whole bunch of pods in the running state here on this cluster. And those are all of those pod replicas are actually being created automatically for me by this deployment controller right down here. So the deployment controller, I can basically scale using the kubectl scale command here. And when you run kubectl scale against a deployment controller, you can specify this replicas flag that it's complaining I didn't specify here because this is not a full command for kubectl scale, of course. But what I've done is basically told this deployment that I want to scale up to 16 replicas. And what the deployment controller does is it creates this resource in Kubernetes called a replica set. Then the replica set itself is going to actually take over spinning up those pods on behalf of the deployment controller. So the deployment controller is kind of a step above the replica set here. If you were to, say, deploy a different version of an application that uses a different container image, then your deployment controller will actually create an entirely new replica set with a different name here. So it would kind of randomly generate a different suffix for the name of the replica set, and then it would actually transition from the first replica set over to the other replica set. So that's kind of how things work here. But then once this replica set has been created, it will go ahead and actually request to the cluster to create all of these different pods. Now, what happens if our pod configuration is requesting more system resources than what's available on our cluster? So I'm actually going to bring up the console for AWS right over here. Let me just grab that tab. And over here in the AWS Management Console, of course, this kind of depends on which cloud vendor you're using. I just happen to be using AWS here. But if you're using Google Cloud or Microsoft Azure or any other cloud vendor, you'll be able to kind of explore that cloud vendor's features here in EC2 or in their virtual machine configurations. And in Amazon EC2 specifically, you can see that at the moment, if I sort by name right here, you can see that my Scrumptious Hideout cluster here has, let's see, 1, 2, 3, 4, 5, 6 nodes running inside of it. Now, if we were to request even more replicas of a particular pod, then if we didn't have enough compute capacity here, the cluster autoscaler will actually scale it up for us. So let's actually try that really quickly. So I'm going to do a kubectl scale. We'll say deployment slash my web app, and then we'll say namespace default, and I'll say replicas. It's kind of a hard word to type. And then let's say just 30, something that's quite a bit more extreme. And it looks like it's not going to find it because it actually changed the context on me. So I'm going to change my context back here because the other cluster finally finished creating. So it added that to my kubectl configuration file. So I'm going to switch back to the Scrumptious Hideout context and then rerun that command. And let's see what happens. So it says deployment scaled. And so now if we do a kubectl get all on the default namespace again, we should see that the replica set should have spun up a whole bunch of extra pods. And sure enough, you can see there's a bunch of pods sitting in the pending state. And that's because there's not at the moment enough compute resources for running those pods. And so if we take a look at the AWS Management Console over here, let me bring that up. So if we go down to the auto-scaling group for the Scrumptious Hideout cluster here, so let me figure out which one that is based on the resource tags or perhaps the capacity here. So as you can see, this one right here actually has a maximum capacity of 10, and it actually looks like the cluster autoscaler has already scaled it up to 10 nodes from 6 that we just saw before by counting them up in the EC2 console here. And if we go back over to instances here, you'll probably see that there's a whole bunch of new instances running. So now you can see that we've got 10 different EC2 instances running to support that cluster. A bunch of them, as you can see, are in the initializing state right over here. So those are brand new nodes that are just now coming online, and they have not yet fully initialized, meaning that our pods are not going to be able to run until they're actually joined into the cluster. So as those nodes actually continue to spin up, you're going to start to see that more and more of these pods become in the ready state down here. So right now we've got 18 out of the desired 30 in the ready state, and as those additional nodes come online and more capacity is available, you'll start to see that number progressively increase. So that's kind of how the cluster autoscaler feature works in action. But let's go ahead, and now that our new cluster is completed creating here, it looks like it's called Wonderful Monster. So this is a brand new cluster that I just provisioned with EKS-CTL, and we're going to go through the process of actually installing the cluster autoscaler on this new cluster. So we'll do that in the next video. I hope this has been informative for you, and I'd like to thank you for viewing.